Right, I thought I'd better do an update on the Fadal. In a nutshell, nothing's happened really. I've had it connected and I've had it all moving, running around. But then I stopped. I found a couple of issues. Got a warm ball screw in the X-axis, so I pulled that off. I've got a little issue with the spindle. It's a bit growly on the bearing, so that needs bearings replacing in the spindle. So I left it. I didn't really have time with the routers and everything going so well. I've had to leave it. So, but what has happened, what I did do, oops, I've done it again. I bought this beast. This is an Urco, was an Urco BMC 40, much bigger machine than this. I bought it, when I first bought it, when I went to look at it rather, it was working with all its original control and everything. When we got it back here, it wasn't working. I think someone's done a number on us. Anyway, cut a long story short, a lot of arguing and what have you, I was stuck with it. So, what to do with it? The obvious thing really, rip off the control, replace it. It's an old machine, it's 27, 28 year old, something like that. It had Urco's own proprietary WinMax, Unimax or whatever they call it, on it, ancient. The engineers were contacted, wanted a fortune, they wanted something like 500 quid just to come out and look at it without putting any boards or whatever it needed. It were just not feasible. So we put the same control on it. Basically what I've done, it's exactly the same control as that. So we've got two identical controllers when that's working. I haven't put the spindle motor on it. It didn't need it. This has got a Yaskawa servo drive for the motor, servo spindle. So I've used all that, reused that. It had Yaskawa servos and drives on motors on it and drives. The Z-axis one had got issues, so I decided to replace them. Yaskawa are high quality, but they was old, very old technology really, and very expensive to buy even today. If you can find them, they want a lot of money for them. So I pulled them off and used the same system as I've got on that Fadal, although the bigger motors, the 2.2 kilowatt motors, and the bigger size, the 180mm size, compared to the Fadal, which I think about 100mm or something like that, I don't know. 110mm actually, so these are like 180mm. Yeah, it's 24 tool changer on it. This machine, it runs on linear bearings rather than boxways. The roller bearings, they're not ball bearings like your typical I-wings, they're more industrial roller type. Everything about the machine mechanically is sound. There's no backlash, it's no slop in it, it's very good mechanically. I've been over it top to bottom, checked all the backlash across the length of the screw. It's nothing. Don't even need to mess around with compensation. It's that good. All ground ball screws and everything. The rails on it are massive. I don't know if you can just see up there. You can just see. Zoom in. You can just see a rail there. They used 50mm rails or something daft like that. Massive. The linear bearings are like size of house bricks. Yeah. So it's built well. Right, but the original Urco had this bracket on there. You'll see the bracket there. Had a big arm that came up, and on the end of the arm was that thing that's up there. Got twin monitors and a keyboard. It was a great big obnoxious thing. It stuck right out here, and the arm swiveled, and it just took loads of room. So basically we've just made this swiveling, made some brackets there. We can swivel this. This is just an electrical cabinet, and we just put the control inside that. Bear with me, I'll open that up. I've just dropped my key on the floor. I'll be back in a sec. There we go, opened up. Yeah, this is just an electrical cabinet. We've got a couple of relays in there that turn it on and off. This is the back of the control. That's the back of the keyboard, keypad. You can see all the wires, they're all on plugs, and they all go out up through this cable and across the top, drop down into the electrical cabinet at the back. The original Airco, they went down under an arm and went underneath and up the back, but we didn't. These cables are pre-made when you buy them, about 5 meters or something like that, and I didn't really have the length to get underneath and go up the back and to the top of the cabinet. So what we did is we come out the top of the box and we've run across the top. We're dropping down into the back there. So I'll just take you around the back and show you around the back. You can see it's a great big electrical cabinet that had on it. The box on the side there, that's got the transformer in it. This thing's a Spindle Chiller unit. It's for the spindle. It cools the ball screws as well. The ball screws are chilled. On the side there we've got automatic luber for the linear ways. We've got all the air, pneumatics for the tool changer. The tool changer is a combination of air and electronics. Oh, I should say electric motors. Right, starting in the box there. Oh, this is the original Yaskawa servo drive for the spindle. And we've got the drive itself, changeover relays for the high and low gears. Quite a clever setup this. It automatically changes over. We don't have to put any codes in to change over. It does it itself. We can if we want to. We can put an M code in and set it into low box, but if you don't, you can just automatically does it yourself. We're all roughly wired in here still. Just again, I haven't really had time. That's where the original servo drives were, so I've just replaced them pretty much in the same place with the ones from SCGH. These are the absolute drives. We're running on 3-phase, but these drives will actually run on single phase, believe it or not. We did have them running on single phase when we were testing. They run on 240 volt single phase, which blew my mind really. But they do, no problem. Most of this that you see down here is, I've pulled masses, boxes and cards, just loads of them that I've pulled off these panels at back. But this was original. This came with, these are all the contactors for the chip augers, coolant pump, turning on the chiller unit when the spindle fires up. The chiller unit only runs when the spindle's running, or the machine's moving. So that's all original. There's just some relays, but in there, that's where all the tool changing portion of the original Airco was located. And this is the bit that I'm going to pull all out and change. I've just wired it in roughly and quickly to get us going, just to make sure everything works. Well, I'll do a much needed job. I want to add some things into it, so these relays are going to go. I just use them temporary to try things. So yeah, but that's where the original Airco control was. The PC side of it, and the controller was a great big board that went there. So we'll be tidying all that up. And that's about it really. I've added a power supply that's just for the relays. This thing here is a mains filter, filtering the incoming power. And that's just where I've been pulling off various bits. Right, that's it. So I'll just shut this up. And that's the machine. It's a 24 tool changer. Spindle is 6,000 RPM. It's carousel type tool changer. So how it works is in there there's there's an AC motor on the gearbox, and on the end of the gearbox shaft you've got a pin that rotates round, and one rotation of the motor moves one tool position. That was the only bit that caused me any grief in the whole of this conversion. It's nothing to do with the controller at all. It was to do with Erco and how it works. The original Erco board that controlled the tool changing side of it, it had built into it DC braking. It's an AC motor that rotates it, and what was happening is when you tell it to rotate, there's a sensor. So you say, right, rotate one rotation. It goes around, sees the sensor, turns the motor off. But it wasn't stopping instantly, it was getting overrun. So these positions were going out of alignment. So when it aligns with the spindle there, like that's aligned with this position, it was running either that way or stopping too short, whatever. So we needed a way to break it in the right place. So a bit of head scratching on how to do that. If I was using a VFD or something like that, it'd be very simple, but we wasn't. So anyway, turns out I didn't want to buy, you can buy DC braking units, but they're quite expensive, they're like a couple £100. So I looked around a bit, had a look on the internet, and it was quite easy actually in the end. I just used a timer relay, a couple of relays actually. So basically how it goes is you turn the AC power off, then you inject some DC power into the windings. In this case it was injected in for 2 seconds. That breaks the motor. We had to play around with the timings, but it turns out 2 seconds stops it in exactly the right point. We just injected 24 volts DC into the windings for 2 seconds. It stopped exactly the point where we wanted it. That's it, big bang bosh, job was done. It stops every time in the same place, and just messing with the timings we could move it forward or back wherever we needed to. So turned out quite easy really. Spent hours trawling internet trying to find solutions, and that was a very simple one. 20 quid worth for relays and job was done. Right, I'll make another separate video now on the control. I'll turn it on and show you it working. I'll be back in a bit. Cheers.